last time we finished log 15a, and today we're going to continue on log 16. Log 16 is about transformation of logarithm functions. So just like any other functions, we will be looking at the shifting, vertical shifting, horizontal shifting, and vertical stretching and horizontal stretching or shrinking. So let's take a look at these exercises. Okay, so the first function we're going to look at is, of course, log base 2 of x. Okay, and that's our first function. And of course, the next one will be natural log x. Okay, and will the vertical shifting and horizontal shift the same as before? And the answer is, what do you think? Is it going to be the same? Is it going to be similar? And the reflections and so on and so forth. Remember when we did the quadratic function and we did the shifting left, shifting right, shifting up, shifting down, and all of these transformation. That's right. You're right, Andy. They're going to be similar. Okay. For example, okay, so let's look at the vertical shift. Okay, let's look at the vertical shift. Okay, so first of all, let's look at the function, this function, right? We have graphed many times. We have graphed this function multiple times, right? This is a common, this is log base 2x, right? So I'm going to put this like this. Okay. And then we're going to just adjust the view a little bit. And here I'm going to put it something like that, maybe -3. And let's look at some of these properties we are observing. Okay, so this is log base 2x, Okay, so the vertical shift, okay, the vertical shift, we know the domains and range and, asymptotes and so on and so forth. So when we look at the vertical shift, okay, which is in the form of f of x, right, f of x plus a number or minus number, right? So plus or minus number. So in our case, we're going to say, okay, so let's consider in this special case, right? Special case where C is 1, right? So we have the situation of log base 2x plus or minus 1. Okay, plus or minus 1. So the process goes like this, right? We first apply the function, and then the output from the function will add 1, will subtract 1, right? We'll add 1 or subtract 1. So plus 1 is going to be shifting up or down. What do you think?
If it's plus 1, it'd be shifting up.
Shifting what?
Up.
That's right. And minus 1 is going to shift
down.
Very good. Okay. So then we will see this, right? So let's make a table to do this comparison. Okay. I want you guys to make these tables as well. Okay. And we're gonna look at domain and range and so on and so forth. Make 4 columns. All right. So logarithm base 2x, right? So this function, right? And then we will have, you know, +1, -1, or +1. So this is -1, and this is going to be +1. Right? And the graph for the one in the middle, right, it's like that. Okay, and then we're going to do the shifting, right? So we're going to take this picture. And this is the shifting up. This is shifting down. Okay, so we're going to have log base 2 x, just to confirm it. Are you guys graphing it? So this is a -1. We're going to make that a green. This is shifting down. It's shifting down. Okay, and the your conclusion is absolutely correct, right? And the other one, hold on, what did I do? Okay, copy and paste. It's going to shift up. It's going to shift up. So then we're going to look at domain and range. Okay, we're going to look at domain and range. Log base 2x +1. Make this one red. There. So one is shifting up, one is shifting down, right? So this is the situation of a vertical shift, right? A vertical shift. So the function, right? So we want to review this process. Okay, I want to review this process. You are probably familiar with it. Okay, but I also want to just review this part. Okay, the input. Okay, and then we give it to the function. Right, so this is the function. And the function, of course, is log base 2x. And then we produce an output. We produce an output. And this output subtract 1, right? And so that's how it works. And the other one is the output +1, right? You see the difference. We see the difference. We see the difference. Now, let's look at some other features, right? Number one is domain. What is a domain? And what is a range? And the other features such as asymptotes, right? Such as asymptotes. Domain, will there be a change of domain? And intercepts, of course. X intercept and Y intercept. Right? So these are the factors we're considering. X intercept, Y intercept. Okay, so let's see. So what will be the domain? The domain for, log base 2x, that's something we know, right? What's the domain for log base 2x?
X is greater than 0.
That's right, x is greater than 0. Perfect. How about log base 2x -1?
It would be the same.
That's right. Same. They're all the same because in all of these three cases, right, we will process the rule of function first, and we only add one, we only add one, subtract one on the output. And since the output is, it can be any real numbers, what will be the range? This one, the range is from negative infinity to positive infinity, right? So how about the range, you know, after you subtract one, after you add one, what will happen?
It would still stay the same.
That's right, stay the same, absolutely. Perfect. Okay, asymptotes. Okay, what is asymptotes? We understand that, you know, this function, log base 2x, it never touches the y-axis, right? It never touches the y-axis. And the vertical asymptote is here. The vertical asymptote is this y-axis. So what is the equation of the asymptote for log base 2x?
X is equal to 0.
X equal to 0. You got it. You're so good. So how about the vertical asymptote for these other two? Let's one at a time.
Also, X is equal to 0.
X equals 0. X equals 0. Wonderful. Now, X intercept. X intercept. Okay. Oops. What is the X intercept? The X intercept of log base 2x, we know that that's 1, 0, right? So what will be the X intercept for if we shift it down by 1 unit?
2, 0.
2, 0 from the picture. But how would you find it? The answer is right, but how would you find it?
You would make the output 0, and then you would solve for.
We said we said y equals 0, right? Very good. So let's look at the consequence of shifting up by 1 unit. So what will be the X intercept?
1/2 0.
1/2 0. 1/2 0. Very good. But how did you find it? The same way, right? Yeah. So you basically take log base 2x. Okay. If there's any doubt when you look at the picture, guessing the numbers, it's always, you know, helpful to double check, right? So that's the function. You're gonna set the y equals 0, and then you're gonna solve for x, right? So log base 2x equals to -1, and x equals to what? Equals to 2 to the power of what? -1, right? And that's 1/2, right? So there's always a way to just to confirm our answers or not. The other one, you know, the one we did earlier, I just want to remind you, these are just barely, you know, input, you're looking for output, output, you're looking for input, that kind of situation, right? For -1, so you have a way to check it. So in the case that you don't have a picture with you, you can still find it. We can still find it. So that's x equals 2. That's how we get x equals to 2. Okay. So this one, of course, the resulting, the x intercept is 1/2 of 1/2, 0, and the other one, which is 2, 0. There you have the geometric aspect, analytical geometry perspective, and you also have this algebraic perspective that we know how to find those points. Okay, so of course this one is 2, 0. That's the x intercept, like we just found here, and the other one is 1/2, 0. The when input is 1/2, the output is 0, which is the x intercept. So now what is the y intercept?
There are none.
Huh?
There are none.
None. That's right. None. Okay, none. So the y-intercept doesn't exist because x can never be 0. In order to find y-intercept, we have to set x equals 0, but x cannot be 0, right? So that's the story. That's the story. All right, so let's look at the other shift. Let's look at the other shift, right? So we have this shift of, we call vertical shift, right? So let's look at the horizontal shift. Let's look at the horizontal shift. Okay, horizontal shift. I'm gonna make this just a little bit smaller, okay? The three cases I would like you to consider would be, I'm gonna still make that table. Okay, so it's make it easier to compare. Okay, so the function we have is still log base 2x, right? But this time, okay, this time we are adding one, subtracting one. By this time, does everybody understand what we're doing here? Yes? So we're gonna do f of x plus 1, f of x minus 1. So this piece is going to be x minus 1, x plus 1, and that piece is going to be x minus 1. Okay, so this was the picture, you know, before any shifting takes place. Okay, and from the way we determine our domain, let's see, what is a domain? Let me put it here. The function goes like x, if x is the input, and we will first do the x plus 1, and then we have, you know, we'll have the function to work on it, right? We'll have the function to work on it. So that's, the function works on x plus 1, and it produces the output, So that's how it works. Does everybody understand this mechanism? Does everybody understand this mechanism? Yes? Does everybody understand this mechanism? Okay, so with that understanding, right? So with this function, and of course we don't have this, we don't need to do this x plus 1. So this is just that. For minus 1, so for minus 1, so this is going to be minus 1. Okay, I hope everybody understand that. Yes, does everybody understand that? Okay, I'm going to make a little bit adjustment. Okay, I'm making a little bit adjustment to the other side. Make it negative. I think this should do. Okay. So now, when we look at f of x plus 1, in comparison with log base 2x, how is the shift? Is it up or down or left or right? Left to right? Is it up or down or left or right?
Goes to the left.
Which one is to the left? Which one?
X plus 1.
Sorry?
X plus 1.
X plus 1 will shift to the left. You're absolutely right. Okay, so we're going to see that this picture is going to shift to the left. Excellent. And then we're going to determine the domain, right? We're going to determine the domain. So x plus 1. And we make it green. You're absolutely right. It's shifted to the left, right? And the other one will be shifting to the right, right? Okay. Wait a minute. What's going on here? Copy. So this is going to be X minus 1. So red, shift it to the right. Okay, so we got it right. Huh, look at that. There we go. Wait, what are you guys doing? Sorry, guys. Hold on. Hold on. It's the okay, what's going on? Oh, sorry. The software is not, extremely robust. It cannot take the torment of me. Cannot take my torment. Okay, domain and range and asymptotes. Domain and range asymptote. Did we give the equation of asymptotes? Yeah, we did. We did all of that, right? So let's look at the domain, range, and asymptotes, and intercepts, and so on and so forth, right? So we're going to insert a couple of rows. Now, domain. We should know how to determine the domain, right? We should know how to determine the domain. So for example, how would you determine the domain for log base 2 x plus 1? When we were in log 15, right, we have done a lot of those exercises to determine domain when solving those equations, right? So the idea is similar, right? Similar. So what is the domain for log base 2x, which is the green?
X is greater than -1.
That's right. X is greater than -1, right? So this guy is x greater than 0. How about the last one?
X is greater than 1.
X is greater than 1. Any questions from anybody? No? Okay, how about range?
All real numbers.
All real numbers, once again. Okay, so from -infinity to +infinity. Perfect. Okay, all real numbers. All real numbers. Wonderful. Okay, you can plot some points, and you definitely can do that. And range is found. Okay, so let's look at the so this time I want you guys to let's just still do it by the same order. Okay, so X intercept. X intercept, Y intercept. Made it a little smaller. Does this look better?
Yeah.
We can see the whole of it. X intercept, Y intercept, and then asymptotes. Okay, so what is X intercept?
Zero, zero.
Okay, the first one is 0, 0. The second one,
1, 0.
1, 0, and the third one,
2, 0.
those are pretty easy to identify. Do you know how to find them?
Yeah, you would make Y 0.
We're setting the output equals 0, right? We're setting the output equals 0. How about the Y intercept?
There are none. Well, for the first one, it's 0, 0.
This time is no longer none, right?
Yeah.
Well, the one in the middle, there's none. But how about this one?
That one would be 0, 0.
There is one. There is one. Okay. So how about the y-intercept here?
None.
That's none. Okay, that's none. Well, in the first function, right, this function, the domain includes 0. You see, the domain includes 0. So when we set x equals 0, you can find the y, y value, right? So for input 0 is in the domain. And in the other two, input 0 is not in the domain. Therefore, you're not going to have the y-intercept there. So now let's look at the asymptotes. Okay, we know the asymptotes for this one in the middle is a y-axis, all right, which is x equals 0. So how about the, okay, so determine the intercept. I'm sorry, the asymptotes. Vertical asymptotes. Let's see, what color should I put? A color. I have a prominent color, yellow. Let's see how yellow does it. Okay, so do you guys see that yellow line?
Yeah.
Yeah, it's not terribly nice, right? It's not terribly good. Oh, what color? Maybe try this one, sienna. Oh, it's not too much better, but I could have used the red. I think the red might be better. Okay. So the vertical asymptote here is x equals 0. We all know that. How about the vertical asymptote here?
X is equal to -1.
X equals -1. Very, very good. You guys got it, right? So this is -1. And let's make it red, thick, broken line. Right, so this, and the equation is x equals to -1, right? You see, right at when we have the domain, right? And the vertical asymptote is right here, right? X equals. So how about the vertical asymptote here?
X is equal to 1.
X equals to 1. Very good. All right, is this very easy for you? It seems like it. Okay, so maybe I will have you guys do the next one all by yourself, okay? Hold on. The next one is reflecting. Okay, the next one is reflecting. Okay, the two reflection. Okay, so we got the, come on. Do something here. Okay, there it comes back. Okay, now the next one, you guys are going to work on it. Okay, it's a reflection. Okay, it's a reflection. So what I would like you guys to do, I would like you guys to do negative of f of x. And the other one, so I'm going to put a negative sign here. You see, when we have it too small, let me make it larger. Okay, you're going to do these two functions, f of negative x. Okay, this is a little tricky. Okay, one negative sign is outside, the other negative sign is inside. The consequence is that one is log base 2x, and the other one is log base 2 of negative x. So if we make a table, like we did before, right? And we have the function here. We have the function here, okay? And then we have negative of f of x. Okay, and there's a result there. And we have f of negative x. Does everybody follow me? Okay, so function-wise, right? So the mechanism of this one goes like this. Okay, so let me just take a shortcut. I'm just gonna take a shortcut, this guy, right? That's what we know. On this one, here, on this one, we have this still, right? And we're gonna put a negative sign in front of it. Put a negative sign after we get the output. Okay, that is the negative of log base 2x. Is that clear, everybody? And the next one, however, okay, this process still, okay, and we have a negative x first. So we take the input and we take the opposite of it, and then we put this in the function, and that's how we get f of, that's the log base 2. There's many ways, there's more than one way to write it. I'm just writing it this way. Hopefully it doesn't take that much space. Okay. And the curve in the middle. So now we get to decide domain range. Okay, the picture first of all, right? And you can think about all these things at the same time because they're all connected. They're all connected. Okay, they're all connected. Domain range asymptote, of course, in the intercepts. We know everything about log base 2 already. Right? So it's x larger than 0. I want to give you guys some time to work out the details. I'm going to give a name to this process, okay? Maybe call it flow. In computer programming, there's something called flowing chart. Okay, this is similar to flow chart. Okay, so I'm going to call it flow. Are you ready to answer the question?
Yeah.
Let's go. So what's the domain for negative log base 2x?
X is greater than 0.
X is greater than 0, still the same, right? So how does the picture look like?
It reflects across the x-axis.
Wonderful, wonderful. Okay, so I'm going to just make a little bit more space. All right, so this picture, right, I'm going to still put it here. And then on the same picture, we're going to graph the negative of this function. And we make it red, green. Oh, what I'm doing. I made a mistake. Okay, hold on. Negative. My bad. Okay, very good. Okay, it's just so this piece that was beneath x-axis, the opposite of it is above. And this piece that was above x-axis, and then after you put a negative sign, is flipped to the below x-axis. And the x-intercept is still the same, right? The x-intercept still the same, right? And the range, has the range changed? The range hasn't changed either, right? The range hasn't changed either from negative infinity to positive infinity. This is still from negative infinity to positive infinity, the green, right? All right, so let's look at the f of negative x, right? If the flow goes like this, then what will be the domain?
X is less than 0.
X is what?
Less than 0.
X is less than 0. Your answer is absolutely right. Absolutely right. Very, very good. Okay, how does the picture look like?
It reflects across the y-axis.
Does everybody agree with that? Yeah, does everybody agree with that? Log base 2 of negative x. I'm going to put it red. Okay, very good. Very, very good. Now, what is the range?
Stays the same.
Still the same. Still the same. Okay. X intercept.
Negative 1, 0.
Negative 1, 0. How about y intercept?
Still none.
None. It's none for all of them, right? It's none for all of them. All right, asymptotes.
X is equal to 0.
X equals 0. Same, right?
Yeah.
No change. No change. Very good. Very good. Okay, so let's look at the stretching and shrinking. Okay, the stretching and shrinking. one is the constant is inside, the other constant is outside, right? The constant inside or outside. So let's see, are you ready? Okay, so this time we're gonna look at the stretching. Okay, but C, we cannot choose C equals 1 because C equals 1 doesn't make any difference. So this time we're gonna choose C equals to 2. Okay, so 2 times f of x. So we're gonna look at 2 times f of x or f of 2x. What's the difference? What's the difference? Okay. One is that f of x, right, which is log base 2x, we multiply by 2. And the other one is log base 2 of 2x. Okay, we don't really need this parentheses, but just to emphasize that, you know, we do 2x. So that's the difference, okay? Does everybody follow me? Okay, so this is when we choose C equals to a number larger than 1, C equals to 2. How about C equals to half? How about C equals to half? Right? If we choose C equals to half, then we're gonna have half of f of x, right? Which is half of log base 2x. Okay, we're gonna see these differences, right? So, well, how do I choose C? Because this C is larger than 1, and this one is smaller than 1, right? C are positive, so we choose positive number for C here. We just want to see what we're getting here, okay? And half and f of half x, right? Whoops, sorry about that. Half x. Does everybody follow me? So that is going to be equals to log base 2 half x, or just x over 2. Okay, so we're going to look at these scenarios. We're going to look at the scenarios, okay? So have your paper pencil with me, with yourself. Okay, have your paper pencil ready, okay? We're going to do 2 at a time. We're going to do 2 at a time. Okay. The function is still here, right? So we have a 2 times of f of x, and we have f of 2x, right? And we're going to have the flow. Okay. And this process, of course, we've done that many times, right? F of x. And the output is f of x. Okay, that's log base 2x. And this one, however, you're going to do the function. We're going to do the function, and then we're going to double the outcome. We double the outcome. That's the flow. And the other one, we double the input. Okay, we double the input. Okay, so you can see the consequence is slightly different. So let's see how big that difference is. How big that difference is. Okay, so this consequence will be log base 2 of 2x. All right. Now, this doubling of the output will cause what? Okay, so I want you guys to work on the picture. Okay. I'm going to grab the picture. Okay, I put it right here. That, right? It's being stretched, right? It's being stretched, or whatever you call it. Okay? Stretched. So for the same, except at the point of X intercept, you see at the X intercept stay the same. Okay, isn't that interesting? But it's not entirely out of our reason, right? Because you're gonna set this equal to 0, and 2 times that 0 is still 0. So this X intercept stay where it is. Okay, so let me put in the other rows. Okay. In terms of domain range, intercept, right? Domain range. Okay, I'm going to give you just a little bit more time to think about it. Okay, so you probably are you guys done? You know how to figure this out, right? Just take your time, you get everything, right? Just be patient with ourselves, you can get everything. So this is a doubling. For the same input, you double the output, right? So for 2, the output was 1, now the output was 2, right? Doubled, right? It's the doubling effect. It's a doubling effect. Do you guys see that? The input was for log base 2 of x, it was this high. And for the new function, 2 times is going to be twice as high, right? It's the same everywhere, right? It's the same everywhere. Yeah, double the height, double the output, right? That's the meaning, is that double the output. Okay, so let's do this comparison here. Comparison with you. Okay, so this height, right? So this is red. Wish there's some more AI there for me to do the there. So this piece, this green piece, double the black piece. Do you follow me? That's the doubling. Okay, doubling of the output, because this guy is just log base 2x. You follow me? So the output is doubled. Input doesn't change. For the same input, the output is doubled. That's what it means. So that's how it being stretched. Okay, that's But if you say here, if you say more narrow or more wider, it doesn't seem to be relevant. Doesn't seem to be relevant, right? It's so it's unlike in terms of stretching or shrinking, it might be a little bit better, right? But you still have to look at the picture. But I think a precise description, a better or more concise description will be preferred. I would prefer that more concise description. So what it means is that for the same input, right? So for the same input too, right? The output here is one, right? The height is one. So this height of this black bar is one, and the green one is two. So the height is doubled, and that's the case for everywhere. That's the case for every output. Make sense? So I will find that's a more concise description to my liking instead of just, you see that we don't use wider or narrower because everything is relative. Okay, and let's look at the domain. What is a domain? What is a domain?
Zero.
Still greater than zero, right? Still greater than zero. The domain and range hasn't changed. Domain and range hasn't changed, same, right? How about X intercept?
Still the same.
Still the same. Okay, and if you set up an equation, you set up the output equals zero, you're gonna find the same number. You're gonna find the same number. How about Y intercept?
None.
None. And how about none for Y intercept here?
None.
Still none, right? Still none. Asymptotes.
X is equal to 0.
Yep. All right, so let's look at the next function. Oops, sorry. What am I doing here? There. Okay, so let me remove those lines. Now, let's look at the last one. Let's look at the last one. The doubling is on the input. This doubling was on the output, and this doubling was on the input. So let's see what the consequence, okay? And I do want to remind you that log base 2x, if we apply product rule, is actually equals to log base 2 of 2 plus log base 2 of x. And log base 2 of 2, that's equals to 1. Doesn't that look familiar? Did we do f of x plus 1? So what should we expect? What should we expect?
A shift upwards.
That's right. It's shifting upward by 1 unit. Okay. Oh, sorry. I'm sorry. This is I don't know why this. Maybe I'm just very clumsy. There. Okay, sorry about that. So I'm adding an item. I'm going to put it red. So it's really shifting up by 1 unit, right? We have done this before, right? So let's put all the numbers in place. Domain.
X is greater than 0.
X is greater than 0, right? And the next one, the range.
All real numbers.
All real numbers. And how about intercept?
1/2 0.
1/2 0. We've done this before. How about the Y intercept?
None.
None. Next one. Vertical asymptote.
X is equal to 0.
X equals 0. Has it been easy, guys? Yes?
It's pretty straightforward.
It's pretty straightforward, right? Could I leave the other one for you for the half? Oops. Could I leave this for you? Okay, I'm going to leave that for you, okay? Don't protest. You can do it. I know you can do it. Okay? So this concludes this section of, this piece of exercise. So let's look at the bottom of page number 85. Okay, let's look at the bottom of page number 85, I'm sorry. We have 14 questions. We have 14 questions. Okay, we have 14 questions. Okay. So now, log 16 continued. Log 16 continued. Okay, so let's look at these. Oh, we haven't do ln x, right? We haven't do ln x. Let's do ln x. Do you think ln x will be the same? Yeah. Everything will be the same, right? Not exactly the same, but it will be similar. It will be similar, okay? But I'm going to go over ln x with you. I'm going to go over as ln x with you because some of the intercepts and stuff may not be exactly the same, okay? So it's I would say similar, but not exactly the same. So we're going to do ln x. For ln x, okay, so for ln x, this time you guys are going to take the lead. Okay, this function is absolutely crucial for all of us, for you and me. Okay, you as a student, if I teach the class, I need to know all of them, right? So let's do the shifting horizontal and vertical. Okay, the shifting part. Okay, f of x equals to ln x. Okay. And this one is ln x plus -1, so -1, and ln x plus 1, plus 1. Okay, so I'm going to change it to ln x. There we go. So what I want you guys to do is that you're going to, fill in the blank, even though they are similar, but there's still some minor variations. I want to insert one row here. So just to do the flow. Okay, be aware. What's that? What is that? Okay, guys, I want you to fill in the blank. All right. Oops. Sorry. Last row. Asymptote. Okay, so we made a point. Oh, okay, that's fine. That's fine. Yeah, we're pretty early, right? A lot of people are sleeping in. Okay. Okay. So now I want you guys to do, we start with this simple one, and then we're going to do the horizontal shift. We're going to go through these items one by one. And this time is your turn. You're taking the lead. You're taking the lead. Okay. We need to do some calculation. Yes, we do. Okay, because the answer are not exactly the same. They're similar, but not exactly the same in many situations. Feel free to put some points in place. Okay, we didn't do the points like we did when we were working with quadratic. Is because we have done so many plotting, but you really need to make sure you put in the points whenever necessary to help us see better. Okay, so now I'm showing you how I will be putting some points in place. Okay, and Okay. How are you guys doing? A lot of these things, I already put in this slot. I assume you guys already have done it. The X-intercept is a little tricky, right? The X-intercept here is this dot. Okay, over here I marked some points. I just want to show you. If you want to see a better picture for yourself, or you set up a better picture for yourself, sometimes put some points necessary. It's important. It's important. Okay, we didn't do the one earlier because those are fairly straightforward, and we understand the shifting. We have done shifting, left to right, up and down many times. But with ln, I want you guys to do a little more detailed work. For example, right? ln x minus 1 is the entire curve shifted down by 1 unit. So that means that every input, its output is shifted down by 1 unit. That's subtract 1. That subtract 1 is on every possible output from ln x and subtract by 1, right? So that's reflected on the picture that every point is shifted vertically by 1 unit. And the same for ln x plus 1. So every point is shifted up, right? For the same input, the output is adding 1. So that's the mechanism. That's what the flow tells us, right? That the flow tells us. Now, so let's look at the X-intercept. The X-intercept obviously is not that straightforward anymore, right? So how do you find the X-intercept here? You will set y equals 0, right? You will set this guy equal to 0, right? If we set that equal to 0, what do we get?
E.
Sorry?
E.
That's right, x equals to e. So what will be the X-intercept? E comma 0. So this point is e comma 0. So it's no longer 2 comma 0, right? Yes? This point is e comma 0. Can you mark that? E comma 0. Okay, so I'm going to set up another row just to answer. This is the setup. Okay, this is the setup. Okay, I just put it as how. Okay, to explain how the X-intercept is found. So now let's look at the next one. What will be the X-intercept for ln x plus 1? You will still set the y equals 0, right? And you will find x equals what?
1 over e.
1 over e, excellent. So the point here is 1 over e comma 0. So when you mark this point, this green dot, which is X-intercept, and this point, this red dot. Okay, so let's mark them together, shall we? You see the difference? I'm going to put negative 0.1. I'm going to put a green. To see if that's not. It's not the best I can do. Okay. So let's make it negative 1.5. How about that? E comma 0. Is that good enough for you? Huh. Better, right? And this dot, this red dot, this red dot, right, is 1 over E, comma, 0. Red dot. That's the x-intercept. That's the x-intercept. So let's mark that point. Let's mark that point. Okay, so I'm going to mark that point. And are you doing the same? 1 over E, comma 0. Okay, so let's see, where should I put it? Negative 0.5. And this is a 0.5. I'm going to make it red. So these are the minor details that we need to attend to. Okay, these are the minor details we need to attend to. So that's the point. I need to move down just a little bit, right? I just need to move down a little bit. One. There. Is that better? Okay, so these are the x-intercept. You see, there's some minor details, right? There's some minor details we need to attend to. Well, let's hurry forward. Let's hurry a little bit. Okay, let's hurry a little bit. So this is what we found for that. Okay, and the next one, I'm going to make another table. Okay, so I'm going to spell out the task. Okay, and this time, okay, the minus 1 is inside. The plus 1 is inside. Okay, you see the differences. You see the differences, right? The difference in writing reflected, it's entirely different. So mathematical notation, we must understand the notation. If we don't understand the notation, we're lost. We're lost. We will definitely lost. Not only you will be lost, I will be lost too if I don't understand the notation, right? So it's very, very important. And the flow, these are fundamentals. These are fundamentals. Our flow is constructed based on order of operation. Okay. When you study programming, you're going to be learning how to do flow chart. That's more. That's even beyond. That's more than what you do in mathematics. Okay. It's involved the design of your whole program. So it's also very, very important. But it's on a larger scale. It's on a larger scale. But here we must understand these little details. Okay, so and you see minus 1, plus 1. The parent with parentheses, inside, outside, it makes a huge difference. Right? And we're going to see here is it make a huge difference in terms of domain and range. I mean, in a lot of these cases, of course, the range might be the same, but domain definitely is affected, right? It's affected. So now you're gonna fill in the blanks. You're gonna fill in the blanks again. Okay, right here, right now. 1, 2, 3, 4, 5, 6. Right. So let's see. We have 6 rows. One, 2, 3, 4, 5, Just 5. Oh, sorry. I'm gonna make it just a little smaller. One more row. So 6. Okay, it's the same story, right? It's the same story. Hmm. 125%. So I'll do this. I'm going to change the scale. Well, this is in slightly different order I put here than from when we did it log base 2, but it doesn't matter. You should not be confused by it. If you are, you must ask me and I will explain to you. Okay, I don't think you will be confused by it. So on this one, there will be some more changes, right? There'll be some more changes. We have some time left. We have 8 minutes left. So let's see. Let's quickly go over this so we can complete this part. Okay. Domain. Right. Domain is good. Range.
All real numbers.
Range is the same, right? Excuse me. Domain range, no problem. X intercept.
20.
X intercept.
The first one is 20.
The first one is 20. The last one,
00.
00. Very good. And the how to is pretty straightforward, right? How to is pretty straightforward. You just said ln x minus 1 equals to 0, right? And then you will get x minus 1 equals to 1, right? And that's how we get it done. And this other one is ln x plus 1 equals to 0. And then the normal step you would have taken for to find y-intercept, right? So you get x equals 0, 0. But anyway, y-intercept, what do we have for y-intercept?
None.
None. Yeah. about this one?
0, 0.
0, 0. Yes, that's right. Very, very good. Okay. So it's not that we don't have y-intercept always. It depends on the function, right? Depends on how it's being shifted, right? Okay. Asymptotes.
X is equal to 1.
Yep. Yep. Very good. I think we can touch. So we're done with this piece, right? We're done with this piece. How about the reflections? The reflections is interesting, okay? You actually will encounter these in Cal. You're going to encounter these in Cal. Okay, so let's do the reflections. So I hope we can just at least set it up. Okay, we can at least set it up. And we might be able to finish, okay, the reflections. Okay, one is negative of x. Oh, sorry, negative sign over here. And the other one is negative f of x. F of negative x, okay? And the flow, okay? We've been doing this over and over again, right? Do you think this might help you? I hope so. I hope so. You know, along the way, you're not only building your understanding, you're building a lot of things at the same time. Okay, you see the patterns, you see all sorts of things. Okay, so let's do the flow. The flow here, okay, it's a negative of ln x. You can see the flow is different. Oops. Oh, come on, hurry up. So now, the picture, the visual. What do we get for the visual? Sorry, span. Okay. Let me just make a little bit of adjustment so the picture looks more balanced. So the picture look a little bit more balanced. Okay, so they're all on the same scale, so we can compare, right? So let's look at the domain range and all of that stuff. You don't mind we go over just a little bit, right? Okay, so let's do it. It shouldn't take too much time, too much more time. Okay, so let's finish. 1, 2, 3, 4, 5. Hold on. I'm sorry. This when I'm in a rush, I tend to make mistakes. 6. Okay. Domain.
X is greater than 0.
X is greater than 0, X is greater than 0, and this one X is less than 0, right?
Yep.
And range negative infinity to positive infinity. Right, so the output can be any real number, okay? The range is any real number. X intercept.
1, 0.
1, comma 0. And
then
this
negative
one?
Negative 1, 0.
Negative 1, 0. Wonderful. Y intercept?
None.
None, 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 right? All right, we're making it. And how about asymptotes?
X is equal to 0.
X equals 0, X equal to 0. Wonderful. Very, very, very good. Okay, very good job, you guys. There are two others. Okay, multiply by 2, inside, outside. I'm going to leave that for you. Okay, because I think you guys can do it totally. You guys can totally do it. So tomorrow and today after class, I want you guys to proceed with other questions in this section. Okay, I want you to proceed with that. And tomorrow we'll continue. Okay. All right. Very good job. Do you think you have, through this exercise, you really feel everything is so much more clearer to you? Very, very good. Okay. So I will see you guys tomorrow. Continue to draw, right? To do the flow, Okay, to do the flow. Okay. I'll see you guys tomorrow and have a great day.
Thank you.
Thank you.